And now let's head straight to our next speaker, Natalie Pistunovich from Aerospike. Here we go. Good afternoon, Natalie.
Hi, how are you doing?
Great. From morning time zones to afternoon time zones.
All around.
Yeah, so you're going to talk to us about high availability, classic and well discussed, but then again with lots of new angles to explore. So let's go straight to the talk, and then we can.
One quick thing, if I may say, I'm inviting everybody in the recording to join the game on our Twitter, but we moved it to our Discord. So all the questions, all the answers in the video, with them, please go to our Discord, not to the Twitter. Thank you.
Now we're curious. So guys, on Discord, some challenges on the talk, and you'll definitely want to answer these challenges. Good luck on the talk, Natalie.
אחר הצהריים טובים. ברוכים הבאים להרצאה על Highway to High Availability. אני נטלי, ישראלית באירופה כבר 8 שנים, ומוסרת דש מהקריסמס לוקדאון פה בברלין. אני נמצאת בטוויטר, ההנדל שלי הוא Natalie Pist, ואני עובדת בתור Lead Developer Advocate ב-Aerospike. Aerospike זה NoSQL Key Value Distributed Database, שנמצא בשימוש בעיקר לשימושי real time. אני אוהבת דברים שהם מהירים ויעילים, ואני פה לדבר היום על High Availability. ברשותכם אני אעבור עכשיו לאנגלית. In these slides, you can find answers to some of the questions in our Twitter game. If you want to participate, our handle is AerospikeDB. If you learn anything interesting, please share using the conference handle, that's TLV Community. So, high availability, what is it? It's a characteristic of a system which aims to ensure an agreed level of operational performance, usually uptime, for a higher than normal period. Who needs it? Traditionally, you can give as an example a data center, but these days, very few can afford not to have it. How to achieve it? Easy. Make sure your system doesn't have a downtime. Thanks for coming to my TED Talk. But if we have to dive in a little deeper, you can say this can be broken down to 3 parts: the architecture, how you build the system, deployment, how you run it, and monitoring. Make sure it runs well. Let's start with architecture. The 2 most commonly used high availability clustering configurations are active-passive and active-active. Active-passive requires at least 2 nodes. At least one of them is not active. That's the failover or standby node. And when a client connects to this 2-node cluster in such configuration, they actually only connect to 1 server. The biggest pro of such a setup is that it maintains uninterrupted service for customers, and it deals well with either planned or unplanned service outage. Then there's active-active. This setup also requires at least 2 nodes, both actively running the same kind of service simultaneously, and there's a load balancer that distributes the workload across all nodes to prevent overloading a node using an algorithm like round robin. The more nodes you have available to serve, the better the throughput and the response time will be. And you have the option to utilize the cache for storing data from users. Next step, deployment. One configuration you can use to deploy is multi-site clustering, where the nodes are comprising a single cluster are distributed across sites. It can be a physical rack in a data center, an entire data center, an availability zone in the cloud region, or some combination of those, just like you can see in the image. The cluster is stretched across the regions and across the different cloud providers, and I wouldn't be quick to recommend to have a replication factor of 5, like in this example, but it's possible. And when you need to expand, you expand horizontally. This uses synchronous replication to deliver a global distributed transaction capability. The update speed is only limited by nature, for example, speed of light. Then you also have the option to go asynchronous, in which case you would go for the XDR, or cross data center replication configuration. In such a setup, you use asynchronous replication to connect the clusters that are located at different geographically distributed sites. This can also be a physical rack, cloud, or some combination of those. And you get to extend the infrastructure to any number of clusters with control, flexibility, and ease of administration, faster writes, and regional autonomy. The shipping algorithm we use at Aerospike for such setup is LUT, that stands for Records Last Update Time. This results in simple and efficient metadata management, easy resynchronization of data center starting at a specific point of time in the past, and it supports dynamic configuration of any pair of source and target sites. And there's independent shipping between them. Basically, you get to expand vertically. What happens if you have write conflicts? Great question. I would recommend for this case to go to the DevOps Days 2019, so last year, YouTube videos, and find the talk about strong consistency in databases and what does it actually guarantee, as my VP of Engineering, Andrew Gooding, gave. Last on our list is monitoring. If you don't have SLAs, you don't fail in them. But there's more than just SLAs to think about. So SLA stands for Service Level Agreement. This is basically what you agree with a client or with your customer as a measurable metric. If you don't meet that, you're probably going to have to refund or pay them as a compensation. Then there's SLO. That's the Service Level Objective, and that's a precise numerical target for a measurable metric that is defining a reasonable downtime internally. And you want to set that stricter than the SLA. And then there's SLIs, which is Service Level Indicator, and this is what actually your system performs. In an ideal performance, this would be stricter than the two before. So let's say, for an example, you have a SLA with your client of 99.95% of the time uptime, then you would want to send an internal goal, so SLO, for example, 99.96% of the time. And if your system operates well, you have SLI, for example, of 99.97% uptime, and you're doing good. And that's all you need for a high availability system. Let's recap. We talked about three parts: the architecture, which can be active-active, active-passive. We talked about the deployment, which you can configure as multi-site clustering or as a XDR cross-data center replication. And you have the part of monitoring, where you look at SLAs, SLOs, and SLIs. And that's it. I want to say thank you very much. Please follow me on Twitter. Please participate in our game on Aerospike DB Twitter. And please share anything interesting you learned on the conference Twitter at TLV Community.
Natalie? Hey, we're having you back.
Thanks for having me back.
Yeah. Yeah. First of all, it was good to have the intro in Hebrew for the locals there. It was a good touch. And I want to actually it's like we've been discussing for so many years about AI availability, but I was wondering now that we see like the shift to the increasing importance of availability, in the CAP theorem, so that many organizations, especially the SaaS, the online ones, they put more weight on the availability side. How do you see that change manifesting in the way people approach high availability these days?
The demand definitely is growing. Less and less organizations are able to afford not to have this to repeat the message of this talk, but also the previous talk. It's interesting how similar the focus and the content is. Like that also gives you this indicator how this is the focus of these days. Yeah. Yeah,
indeed. I guess all of our industry, and especially in the track that is the Statscraft, it's what we do on a daily basis. So thanks
how
a lot
do you measure your
joining us from Berlin and for sharing with us this talk. Thank you.
Thank you.